Hey guys, it's Johnny again. This time I'm going to show you how to set up this matrix code post-process material that I've been dorking around with here recently. Let's get to it. One quick note about this material is that it's essentially just a scene depth outline with a panning world aligned texture. So you can see the combination of what's going on here. Okay, so the first thing you want to do is go grab a tileable matrix code material. I actually grabbed this one and already I just brought it in here. I didn't mess with the compression settings or anything like that. This is from Progressus, user Progressus on DeviantArt. I just downloaded it from there. So after you've got that, you want to come here, make a new material. We'll just call it m underscore code post or something. Code pp. There we go. Alright, we want to open that. You want to click on this made node here and then come down here to material domain and set it to post process. Then you also want to come down here and change blend to before tone mapping, because doing it after tone mapping gets a bunch of jittery results when I use it. So after that, we want to come here and say texture object, not a texture sample. You want a texture object, and it should populate automatically with what you had selected. I had mine selected, so it's in here. If it doesn't, you can come right here and put yours in there. So you want to do that. We're also going to be using, we're working on the world aligned texture portion of it right now. So the next thing we want to do is grab a material function called world aligned texture. Oh, there we go. Yep. So that's going to map a texture or project a texture on our whole world based on world position. So as an object moves through it, I'll show you when we wire it up. It moves through it, it looks like the texture is constant and the object is moving through the texture essentially. Okay, so we'll wire this one up to texture object, texture size. That one's kind of self-explanatory. It's controlling the size of the texture there. It says vector 3, but you can give it a single value here and it'll be okay. 200 was how I did it. To my taste, you can adjust that to whatever you're liking. World position, this should be wired for absolute world position internally, but we'll change this later. I'm going to show you how this works for now. Export float, we're not going to bother with that. I'm going to leave this for now to show you what it looks like if we don't adjust it. And that should be good. Now we're going to take XYZ texture out. Pop it to emissive color. So now we're going to come here to apply it. We'll go to post process here. Post process is volume. Search for material. And post process materials. You come down here. Add an array element. Asset reference. Grab our material here. Oh. Boom. Okay, that's real ugly, but it's a start. Okay, so you can see that it's at least mapped some way. It's mapped this way, right? But we're getting all this weird stretching on. We're not culling anything at distance or fading it or blacking it out or anything like that. But it's mapping this way. We'll go in here and fix that. So let's go here. Okay. So we're going to fix that with world space normal here. So what we're going to do is right click, scene texture. Where is it at? There we go. Scene texture, and then we want to come right here to texture ID and change that to normal. Right, then we're going to take that color, bring it in. That's looking kind of funny here, but if you give it something that has actual strict direction there, it looks good. So we'll apply that, jump back in. Alright, now it's at least a little different, right? Now we're projecting right in two different directions there. Sorta. There's there's some issues with transparency you can see on this window of this truck here. So for panning, we're going to take a time input, and at least for now, I'm going to show you with this world position input right here, that material function. So you can go time, right click, time, boom. We're going to multiply, hold M and click. For our mask, we actually want to take the Z and move it, right? So we'll just move that. We'll go those guys, and then another one, and we'll leave this one as just RGB. So it's RGB XYZ. If you ever want to know, you can look at this little widget right here. It's red for X and green for Y and blue for Z. So since we want it moving in the Z for now, we like that. And we'll multiply actually want to add, so we'll come bring these guys over here. This can just be how fast we want it. We'll multiply here. Well, I don't know what's a good value for that. We'll play around with it. I don't know. Okay, so then we'll come out of here, add. Right, and so we're adding Z position. We're moving it in the Z, but then we're going to bring these back together over here so we can append that vector with that Z and then bring that into world position. Alright, you can see it moving. Apply that. We'll apply that and then we'll jump back in. Alright, so now we at least got something panning here. Okay, so to get the code raining down the walls, right, in the Z, but also panning across the floor like in the hallway in the Matrix when Neo finally realizes that he can control stuff, and you see it panning across or moving across the floor there as well as raining down the walls. So to do that, we can't just, with this material function, we can't just do the same thing here and append stuff together, because what we're going to end up is with this raining down but also moving sideways when we've got this one going across here. So what we're going to have to do, what I did was I made a custom version of world align texture material function. So we can just break these links, and I will drop mine in. I'll get rid of that. Come in here, world aligned. I just call it ZPan, I'm not sure why. Okay, same thing, we're gonna wire up that, texture size 200. Okay, so now we can save all of this stuff because it's going on inside. And now I've got inputs here for how you want the XY faces and the Z faces to pan. Right, so I'm going to feed them some values. We'll also do same thing here, world normal in. This is 6 of one, half a dozen of the other, depending on how you wire it inside, with whether it's negative or positive. Just depending on which direction you want that to pan, You do want them to be the same, even if it's negative, right? You want it to be the same value, positive or negative, to keep the speed the same. Let's wire XYZ up. Okay. Alright, now look at that. We got it panning across the top and raining down the side, so we'll jump back in. Alright, there's something. So it's still super bright and ugly, and everything is just insanely green and overwhelming. So we're going to fix all that too. But first, I'm going to show you what's going on in here. So, open this guy. What'd I do? There we go. So what's going on in here in my little custom version of that is I actually broke out that world position that we were manipulating before to make things pan. I broke it out into individual components for X and Y and then Z here, right? So we're feeding, again, like we did before, time multiplied by some scalar, which we fed in, adding it, and then we're appending based on directions there. This is the only stuff I actually changed. So we've got the code raining and panning across the floor, but it's still super overwhelming. And if you looked, it's even drawn it on the skybox because there is no distance right now. It's drawing it on everything. So that's a big contributor to it looking super overwhelming. So we'll jump back to it. And we're going to just move these guys over. And then we'll right click, we'll get a lerp. Let's actually do that. Feed this into here. And then we'll hold 3 and click. It's going to get us a color. Boop. Vector 3. I leave that black. That's just going to, that's what our distance, you know, we'll treat it like distance fog kind of thing. That's the color off in the distance. So then it's going to linearly, if you don't know what a lerp does, it linear interpolates between the A and B based on alpha, right? So you just feed it a value like distance, like we're going to, and it'll fade to black here. So then we can get absolute, oh, nope, it's world position, even though it says absolute world position. Okay, and then we'll grab camera position in world space. All right, we'll do a subtract. Get us the difference. And we want to get the magnitude of that vector, so we can just go vector length, I guess. Yeah. Whoa. Okay. So now that we get the magnitude of that vector, we can divide over the distance that we want it to fade. So I'm holding 1, clicking, hit a constant. We'll say like 20,000. That's what I was using. Okay. Should be able to feed that. There we go. So now all the stuff off in the distance this is going to be our distance to fade completely to black, right? So there we go. Now our skybox is no longer overwhelming us. So now they're just fading off in the distance. So if you scroll through here, you'll be able to see stuff starting to come fading out of view. That building way out there. The next element that we want to add is that outline to objects. So you can do it to taste, but I like the outline because I think when an object's moving through the world and the code is, you know, the object is moving with the code panning across it, things just don't really have any shape. You need some kind of consistency, in my opinion. And so things that are static in the scene can look good with just code, but I like the outline on things that are moving, and you know, I left it on the things that are static too. So we're going to come down here and let's see, scene texel size. So you want to be offsetting by texels as the Unreal docs recommend when you're working with scene depth and scene color. If you want to learn about texels, there's a rabbit hole you can go down and look at all kinds of videos on that too. So I'll link a guy in the description that explains texels too when you're modeling and that kind of thing. We're going to grab a screen position because we're working in screen space now. We're also going to get scene depth because we want to know how far into the scene these pixels are when we're working on them. So we're really just going to approach from the top, the bottom, the left, and the right from an individual pixel. We're going to look at those values around it to find out whether it's on an edge or not. And you'll understand a little more here in a second. So the first thing we're going to do is we're going to take texel size. Actually, we don't have to worry about that yet because we're in offsetting. So the first one, we can just feed straight into there. Right, and then we're going to come out of here and multiply. Actually, yeah, I could multiply. Since we're going to be doing it from 4 directions, we'll do -4 here. Top, bottom, left, right. Alright, so we'll go ahead and bring this guy out. Add. There we go. Alright, now we can worry about how we're going to start offsetting things. So we're going to treat this as our center pixel here, and then we're going to offset in the top, bottom, left, and right by using blur sample offsets. So this gives us single offsets to the bottom, right, top, and left. And you can also change that step size if you fed something in here. If not, then it just goes by a single step here. I believe the origin of the screen is top left, right? So +1 is down in the Y, and +1 is right in the X. I jumped ahead so you didn't have to watch me wire all of this together, but now I can explain what's going on here. So we're going to offset in all 4 directions around a center pixel by a scene texel size, right? So this 0, 1 is down, it's 1 in the Y. And we're going to add that to our center pixel position here. Then we're going to get that scene depth value at that position. We're going to do the same for these other 3 directions. Sum all of these together, and then if we happen to have depth difference in those pixels, we'll have a positive value here. So then we're going to come out of here and clamp this between 0 and 1, and I can feed this into, should just be able to go here and show you edges. There we go. We'll jump back in here, and now you've got edges on everything. So now we want to come back here, and we can put these together. So what I want to do is I still want these guys here. We'll move them down because we want this effect added to this effect, but we still want our distance fade here. So leave that like that. We'll come out of here and just say add. And now we'll bring that guy there. And this will go into the lerp. And then we'll come out of here. This is spaghetti, but since you're watching it happen, it shouldn't be as complicated as looking at it when you didn't watch it happen. Here we go. So now we've got edges, but our edges are white, right? So we got our code raining and panning, but our edges are still white. So we can come here and take this value. I'm gonna hold 3 and click to get us a color here. We'll just do something like that. And we can even hold M, click, multiply this value times our color, and then bring this up in here to the add. And now we're getting our green edges instead of our white edges. Let's jump back out and check it. Boom, green edges. That's it, man. Hope this helped you guys out, and if you want to help the channel out, tickle that little like button. Either way though, I'll be back with another video. The next one should be on making the NPCs in the city killable, ragdolling, and you can hit them with cars and stuff. So, should be a short one, but I will catch you guys then, later on.